weird. And I also have nifty, high-speed, revolutionary wristbands from Trusted Sec if anybody wants, and you can pick them up here. They glow in the dark, which is really cool. It's good for clubs. One sec here. Why aren't you? There we go. So when I came up with this talk topic, I started looking at different ways that we break into systems. And I think I have an introductory slide here, actually, too. Oh, yeah, never mind. Anyways, I'm Dave. I started Trusted Sec. I'm the author of the Social Engineer Toolkit, Fast Track, a bunch of other stuff. Author of Metasploit, the Penetration Tester's Guide. I was in the Marines, and all that good stuff. Speaking of which, I'll be speaking at DEF CON. Anybody going to DEF CON? No? Anybody going to DerbyCon? Sweet, that's good. So DEF CON I'll be speaking, and I'll actually give you guys, are we recording?
Yeah.
Okay. All right.
Pause?
No, it's okay. So there's a whole thing here that I have to pause because I say stuff here that I wouldn't share with the public. But I'll give you a quick introductory of what I'm going to be presenting on at DEF CON, just to show you some of the cool stuff that we're going to be releasing there and the tools. But I'll show you that when we're not recording later on.
If you want, I'll just not post it until after DEF CON.
That's all right. You can just do this, and we can pause it. Or I don't care, whatever. So this talk is around what when we do penetration tests. The common ways that we break in through systems is either through passwords or things that we don't need to worry about passwords with. Now, what we're taught traditionally is what? What are we taught in traditional methods of password cracking? Anybody know? Dump the hash values, right? Maybe use rainbow tables to crack it, right? And then from there, if it's got a weak password, if they're using LM, we're good, right? If they're using NTLM, we might have to brute force for a while using John or CUDA servers or ways of doing mathematical computations to break into stuff. So that way is kind of old and antiquated. It's rare that I actually do any type of hash dumping anymore. And reason being is there's so many other methods out there that are so more easier to do that you don't really need to work on it. Now, ultimately, at the end of the day, when you get domain admin rights and you compromise the system and you get access to their systems and everything, dumping the hash values may still be pertinent to see how well they're doing on their passwords. But at the end of the day, passwords pretty much just suck. Even if it's a 50-character password, 100-character password, it doesn't matter anymore. We're pretty much done with those. So passwords are kind of antiquated and out-of-date type technology that we're using. So we'll talk about why even crack passwords today. So the first method is my favorite. And this is, yes, sir? You'll see here in like 2 seconds. That's great. It's a great question. How does Microsoft know that your password is if it's hashed? And the truth of that matter is they actually they hash it, but they actually store clear text values in memory, and that's what we're going to talk about here. It's great. Good question. Yeah. So my favorite is there's a couple of tools out there. One's called Mimikatz, another one called Session Dump, another one called WCE, Windows Credential Editor. And I'll show you examples of this. I'm actually going to do a live demo. But with WCE and with clear text passwords, a bunch of researchers about a year ago, 2 years ago, found an undocumented feature within LSASS. And what you could do is you could query LSASS to extract what's called WDigest. It was an old WDigest legacy password storage feature within Windows, and actually allows you to extract any of the logged-in user accounts, usernames, and passwords in clear. So what you can do is if you have a 50-character password, it doesn't matter. You just extract the clear text password, and you have full access to it. And so when we're doing these type of pen tests, when you find systems open, we just dump the live individuals' usernames and passwords in there, and we just use that to go into other systems. It works perfectly. What'll be funny is you don't even need to use that too, but we'll get into that in a little bit. But because clear text passwords are kind of like old too. I mean, who cares that you have a clear text password? So let me show you a quick example. So here's one. Oh wait, I changed the password here. Hang on. So I'm going to use the ever so powerful Social Engineer Toolkit. Obviously, I'm a little biased. And what's that? What? There's nothing on here. So the Social Engineer Toolkit, if you don't know, for you folks, everybody that hears me talk, I always mention the Social Engineer Toolkit, and I apologize if I'm repeating, but it's like my baby. And the purpose of SET, and we just used it today on a successful pen test, is to really try to attack the user population and not have to worry about traditional methods of detection. Now, you might have heard of common terms like antivirus and Java exploits and buffer overflows and 0 days and all that other stuff. The thing with the social engineer toolkit and why it works so effectively is it doesn't take advantage of any exploit. It actually uses the user trust relationship to make it actually an effective attack. And so, funny story, every time I released a new version of SET, the antivirus vendors would go to my website and download all of my binaries, all of the applets, and they'd write signatures around it. So I got mad, and I just did mad coding for about 2 months. And so the way SET works now is every single time you generate a Java applet or a payload, it actually encrypts the entire PE file in AES-256 encryption with the dynamic cipher key notation. And then it does stupid stuff like it'll base 64 something random amount of time. So like a payload may be like, it'll base 64 something like 500 times. So you actually have to base 64 it, see if it's legit, base 64 it, see if it's legit, base 64 it, see if it's legit. Then hopefully you have the dynamic key, then hopefully you can decrypt it. So it's been working pretty well. And then the major issue is the Java applet, which has been detected a lot. And so what I did is I wrote a complete polymorphic, randomly generated every single time AES-256 encrypted Java applet as well. And that gets uploaded to GitHub every 2 hours. So if you're getting flagged by antivirus, just do a git pull and you're all set. They gave up after about they gave up after about 16 tries. So you don't have to worry about antivirus and things like that anymore. So it's a good thing. These guys make me mad. When I'm mad, Hawk mode gets activated. So my IP address is 192.168.9.229. And I'm just going to clone a website. I'll just clone TrustedSec so I don't get in trouble with anybody else. And we clone it. And what's nice about this is, again, it doesn't take advantage of any type of exploit. In fact, Java 7 Update 21 actually targeted a feature in SET to make it so that you actually had this. It would actually say, "Are you sure you want to run this? It has potentially unsafe components." So on a plane ride back from Florida with my family, I rewrote it in about an hour, so it doesn't have that anymore. So you don't have to worry about that either. And then what you can do in this method is there's what's called PyInjector and multi-PyInjector. Injector. And what it does is it actually shoots shellcode straight into memory without ever touching disk. So things like whitelisting, blacklisting, things that may be detecting writes to the disk wouldn't get detected in this type of instance because it shoots right into memory. You don't have to worry about it. Okay? And it's all AES-256 encrypted, random cipher keys. In order to do it, you actually have to pass the cipher key and the shellcode to it in order for it to actually execute. Let's do one. So we generate our shellcode, which is a Metasploit payload, and it's byte compile or manually patch the shellcode on the fly. And so we get everything loaded, and the reason I'm showing this, by the way, is because I'm going to get an interpreter shell. I'm going to show you how to dump clear text passwords. But let's just take a Windows 8 instance. Now, when I wrote SET, I wrote it for Windows 7. When Windows 8 came out, can anybody imagine what it took for me to get it Windows 8 compliant? It's a lot, right? I had to write now compatible with Windows 8, and then I updated the documentation. So it worked out good. About 30 seconds, It takes a while to add the commit and then change the documentation to say now Windows 8 compliant and log in the computer. It takes a while, right? So what we're going to do is we're going to browse this website, and this is a fully patched Windows 8 machine. And again, this is taking advantage of trust. Now, there's a couple of ways to make it more believable. Why is this taking so long? There we go. So there's a couple ways to make this more believable. One is getting a digital certificate, a code signing cert that's signed. And it just takes $250. $50 to register an LLC in the state of Ohio, and then $200 to buy the code signing certificate. So I own verified publisher and secure applet, and I own 50 LLCs that I never use, which I think is illegal. But anyway, I should probably decommission those. But anyways, I think if you don't use it for 2 years, they get rid of it. But here's an unsigned one. I don't use them. There's no money going into them. So you go to this website, and it looks like TrustedSec in every way, shape, or form. And you're going to get this nasty lookup, but again, based on how you actually do your pre-tax and your attack, it makes it look a lot more believable. Oh, my Java version's insecure, so I have to update. I updated yesterday. Never mind. Makes sense. So we update. We're updating a second. And you get my website, and it's a little slow because of the internet connection. Oh, there, I did edit. So you can see that this is verified and trusted, secure, and safe. It's a verified certificate. Everything looks good. So would you run that? Sure. Right? As a user, I would. Nothing that strikes out as me. As soon as I run it, it redirects them back to the legitimate website, and then back here, I get all my shells, and they're going to see them popping back here. It's doing all its decryption routines right now, so it takes a second. And now we have full access to this computer. And what's cool about this is it actually takes advantage of like egress busting. So a lot of people place egress filtering in place so you don't allow certain ports out. So this kind of bounces different ports looking for a way out, and once it does, it actually gets in.
You got multiple sessions.
Yeah, so I got multiple sessions as it bounces out, right? So common ports here, 80, 80, 25, 443, 80, 21. Now, interesting fact, in Windows 7 and above, Microsoft released a flag called the stateful FTP. And it actually breaks Meterpreter. So you actually can't get out port 21 on standard Windows 7 and Windows 8 machines because of the stateful FTP inspection that it does. However, my version of set disables it for you so you can get out anyway. So it works out. So we have our session, right? And this is a fully patched Windows 8 machine. And hopefully it works on Windows 8. I didn't even try, but we'll see this in a second. First thing we need to do is elevate the permission to system. Now notice here I get access is denied. So let's go bypass UAC real quick. Sorry, hang on.
What levels of UAC does this work with?
All of them except for the most restrictive, that prompts for username and password every time. Now, for those of you who aren't familiar, UAC, user access control, you get that annoying pop-up, it's like beep, yes, beep, right? That's trying to protect you from elevating your permissions to administrator. A few years back, this is a long story, so if you've heard it again, I apologize. But Kevin Mitnick, a good friend of mine, was doing a pen test, and he's like, hey, Dave, have you ever ran into UAC before? And I'm like, no, not really. And he's like, hey, do you mind taking a look? And so I started looking, and we had a bypass in about 3 hours for it, and it still hasn't been fixed today, which is good.
The important thing is the most restrictive mode of UAC does work.
Yes, the most restrictive mode that requires you to enter your password in every time it elevates the permissions does stop this attack. And reason being is, it's a long story, not to get into the actual exploit itself, but when you log into your system, processes respond under the context of your user account. So for example, export IDXE is spawned under just to say Dave. Now that certificate, have you ever seen export IDXE ever prompt and say, hey, export IDXE wants your administrative level rights? No, right? And why is that? And that's what I was like, that doesn't seem right. So Microsoft signs trusted processes with what's called a trusted publisher certificate. And that certificate essentially makes it whitelisted against UAC unless it's in its most restrictive mode. So when you elevate those to those specific levels, you can actually prevent this attack from happening if you're using that. But in corporations, we typically don't run into it. And the bypass UAC script was just updated. I put an update to it, like I don't know. Well, let me rephrase that. HT put an update to it after I sent them the code, but about 2 weeks ago, so it's Windows 8 compliant. And I'll just have it run on, let's just say, port 8000. So we'll go ahead and bypass UAC real quick. Maybe not. There we go. Now we're good. So now if we get system on this machine, give it a second. It's got to load the modules. Now we bypass UAC on the Windows 8 machine. Cool stuff. So now we know that there's an individual logged into a computer. It's migrating. And why this is important is when we're doing pen tests, let's just say you find one flaw, one specific exposure, a weak SQL password, or default Tomcat instance, or something that allows an attacker into your infrastructure, or let's just say SQL injection from the internet, you gain access. Now someone's got a shell on this machine, they social engineered somebody. What we need to do now is figure out how to take that concept of where we're at right now and use it to jump to other systems so that we can get access to the crown jewels or get access to intellectual property or things that are very sensitive to the company, right? Or domain admin rights or whatever. And so there's a couple of different techniques out there to use. Now my favorite is either Mimikatz or session dump. Now Mubix, Rob Fuller has a great blog post on how to add session dump to Metasploit. You have to go to basically the GitHub repository for Metasploit and go into the pull requests. And inside the pull request is a session dump pull request that hasn't been added to Metasploit yet. You basically add that in, and now you have session dump available to you. And let's just take a look at session dump real quick. just type in use session not for Metasploit. Takes a sec. Hopefully. Yeah, anything that actually changes the framework, changes the framework or adds any type of functionality that may not be present there goes through a lot of scrutiny. It'll either be added or it'll be deemed not to based on why isn't it?
Depends on what licensing too.
Yeah, I don't know why that's not loading. Well, I may not be doing a demo session dump. Well, as we let that load, what this takes advantage of is that wdigest flaw that allows you to extract all those usernames and passwords in clear text. So with this, you typically would be able to type in wdigest passwords, and it would actually extract all the passwords for you. Let me try using Mimikatz. Huh, all my extensions are failing. Oh, looks like the session died. Try piggybacking it again. Sometimes, you're doing this type of exploit dev, it gets a little funky. Let me migrate to something else real quick. Let's see, I'll just migrate to like, one sec. Give me something good. Just trying to find a good process to migrate to, and it's already migrating it. Maybe because I'm in Notepad. See, when it migrates to Notepad, it messes up. Interesting. What's that? Yeah, it looks like it's already added. It looks like it's added already into the script to automatically migrate the process. So I would typically have to. I'll have to just recode that real quick. I could do it during a break. I'll just recode during break, not to migrate. Actually, just screw it. Let's do it real quick here. Hang on. I'll just do it real quick. Hang on. New directory just freaks me out.
They just added Mimikatz in the trunk.
Yeah. Modules, post, windows, escalate. All right, that should fix that. Let me reload real quick. Not bad for on the fly, huh? There we go. So hopefully this doesn't migrate. We keep our sessions. There we go. Huh? Not bad for on the fly coding. Now if we do get wdigest passwords, now notice here, and of course not. Oh, hang on, I know how to get around this. So it says current process is WOW64. Now this happens when you're running in an individual process that it doesn't support for the extraction. So what we're going to do, we're just going to migrate to a different process. Now hopefully migrate doesn't break it, but we shall see here in a second. Where's Explorer? I just saw it here. Migrate 2744. Give it a second to migrate. And we still have our processes. Let's try again. So maybe, worst case, I could just bump down to Windows 7, which I know it works on. Here, let's do WinLogin. You can do either that or LSAS. What in the heck? Just lost my... All right, I'm just going to bump a Windows 7 machine just to show and demonstrate. Now, again. Yeah, that's not supposed to happen. Oh, you know why? So I have EMET installed on these other ones.
You got your presentations back.
Yeah. So that's why. So EMET was stopping me from that, by the way. So kudos to what we're going to talk about next. Notice it was still possible to exploit the system, just much more difficult, and a whole bunch of things errored out. What's that? Yeah. So let me get back here. Make sure I'm still listening. Yep. Since the website loads, it's a little slow because of the internet connection, but if you're killing the internet connection right now and downloading a bunch of stuff, please stop.
Run this on VMCI.
Yeah. What I could do. Yeah, there it goes. All right. Just slow. You can use templates too within set. I should just use that instead of cloning a website, but it'll load in a sec. So we get our trusted publisher certificate again. And we should get our shells back here in a second after decrypts and everything. So we'll get back into session. Let's just pick 10. So I'm going to have to bypass UAC again. All right. So let's get back to this. Now this probably isn't going to work, so I need to migrate to a process. Yep. So I'll migrate to 564. Sorry, guys. I should have did all this beforehand, but that's right. You see me troubleshooting. There it is, huh?
Nice.
Yeah. So you can see my password is p@55w0rd, and let's just say that was a domain. You know, obviously now we have domain credentials to be able to log into other systems. So a very easy way of getting clear text passwords from a machine that you've compromised. Now, if multiple people are logged into this machine, you'd have all of those. So it just depends on who's logged into the machine to be able to do it. Same thing for Mimikatz. So if we use Mimikatz. Now, we've been noticing some issues with Mimikatz. It still seems a little bit buggy from the fact that some of the systems that we do the wdigest passwords for, it actually errors out on us. So just a heads up when you're using both of these. But you can see here I just type in wdigest. And now we have all of our username and passwords here already. Where are we at? Where's it at? Well, it's supposed to be here. Maybe this is in hex. That's probably in hex. So that's probably p@55w0rd right there. So anyways, just ways of doing it. Got it? Pretty simple, huh? Sorry. Ignore all the issues that I had. Pretty simple, though, if I didn't have emet on there. Now, that attack didn't use any exploit. It's how Java was designed to work. So easy method there. Second method, pass-the-hash token impersonation. Anybody seen this before? This is a pretty old-school method, actually. It's been around for a while. It's called pass-the-hash. Now, the biggest problem that I always had with a thing called psexec and Metasploit was when you use the hash values to then authenticate to another server, the binary would always be picked up by antivirus because it's a known Metasploit payload. So every known Metasploit, even if you're using like Shikata Guy, all of those are all going to be picked up by antivirus typically. So they added a flag called exe custom, which actually allows you to point to your own custom executable to upload to the victim itself. So when you go and you do this now, you can just point to your own custom binary that you've created that gets your own antivirus, which again is not hard. I'll show you how to do that in a little bit. But that allows you to then authenticate to a server and then attack it. Now, let's just show you an example. So I'm just going to go ahead and background this. Now, if you do a search for psexec, it's Windows, it's exploit Windows, SMB, psexec. And this is in Metasploit. There's also a few other tools, and I'll mention one of them later on called SMB exec, which is my personal favorite. But what psexec allows you to do is authenticate to a server with just the hash values. So let's go back to that one session I was just in. Was it session 16? Now, if I dump the hash values for the system, sorry. And it's cool. There's two techniques for dumping there's a few of them, but there's the two main techniques for dumping hash values. One is injecting into LSASS, removing the protected process, and then extracting it from there. The second is the most relevant because what it does is it actually extracts the keys from the registry, then uses that the sys key, the boot key, and a couple other things to actually remove the protections in the registry and then extract all the username and passwords through the registry. Much more safer than actually injecting into LSASS, because LSASS can crash, causing the machine to go down. So you see here we have username, the RID, and then we have a hash value here and a hash value here. Does anybody know what these two are right here? LM and TLM. What's the difference between LM and NTLM? LM's old, but why doesn't it work? What's that?
Why doesn't it work?
Well, why is it easy to break?
Oh, because it's split into half.
Splits into half. So 7 and 7, right?
Characters.
Yeah. So if you have a 7-character, or if you have a 14-character password, it splits it into 7 and 7, right? And it's all uppercase, so much easier to brute force. NTLM fixes that by, if you have a 15-character password, you have a 15-character NTLM hash. So in most cases, we don't really care about this, and most people aren't using LM anymore. Well, I guess that's not true, but a lot of people shouldn't be using LM anymore. You can, I guess, use rainbow tables to crack this. But this side is what we're concerned with, and this is the NTLM side. Now, if we want to authenticate to a server, and think about this, is anybody working in infrastructure or a corporation where they have servers that have the same local admin password on other servers? Almost everybody, right? Yeah, yeah. And if you don't, I'll show you how to bypass that next. That's the next one. But the local admin password is important because you can then attack this one server, right? Then you can use the password on this server, and on this server, and on this server, right? Or if you compromise a workstation, how many local admin passwords are the same on local workstations? All of them, right? So now there's a really cool tool that Rob Fuller wrote. We use this all the time on pen tests. It's called NetView. Ubix wrote it. So what we do is we'll compromise one box, and then we upload this tool called NetView. And what it does is it actually logs into every machine that you have the credentials for, based on your current credential sets. And it actually enumerates who's logged into those machines and what their permissions are. So if I want to find a domain admin that's logged into a machine, I just go to that box. Or if I know who the domain admin groups are, I'll target those individual people, go after them, and then usually they got credentials on there in some way, shape, or form. And it enumerates the whole domain for you almost instantaneously. So you have who's logged in this machine, where they're at, what type of file shares are exposed, all that good stuff, and it's all readily available for you in one command. It's netview space -d and then domain that you want to go after. It's really cool. But you have this administrator account here with the RID, and then you have this hash value here. Now what we're going to do in psexec, I'm just going to copy, I'll just go after the administrator account. So if I copy this, and this isn't going to work because I don't have the firewall on, but I'm just going to show you anyway. So if I copy this part here, okay, and I background this, and now I do show options in Metasploit. Now notice what it's asking for here. First it's asking for our host, which is the remote host. So who am I going to attack? What port am I going over? I'm going to go over SMB. What share do I want to enumerate? The admin share, because I have the administrator local admin hashes, right? Then what domain am I working on? Is it a domain account or is it just the local workgroup or the local account? I'm going to keep it like this. The SMB password, I'm just going to paste the hash values into there. And the SMB user, I'm going to say as administrator. All right? That's all you need to authenticate to another server. You don't have to worry about the password itself. It then passes the hash, does impersonation as an authenticating server, and it says, oh yeah, you're good, dude. Log in. You're sweet. No problem. So I just type in 192.168.1 or 9.254. Set SMB user to administrator. Set SMB pass to the hash value. Now if I show options again, you can see this is all set. All we would need to do then is just type exploit, and it would authenticate. Now again, I'm using a Windows 7 machine, so it has the firewall up. It's not going to allow it, but that would authenticate to the server, allow you to, and then get you an interpreter shell. Now, again, this part right here gets picked up by antivirus. All right, that's a problem, right? Because we don't want to get picked up by Symantec or McAfee or anything else there that just sits there and writes static stuff for a bunch of public things. And so what you can do is do set custom exe and then path to your executable. And that will allow you to upload your own custom malware that gets around things, okay? Nick, can you pause that for a second? I always love sharing the cool stuff with you folks. So this alone is cool. You can upload your own executables. What if you don't want to use your own executable? What if you don't want to touch disk because you're worried about, AppLocker or Bit9 or different technologies that are whitelisting, blacklisting? So what you can do with that is you can use PowerShell injection. And PowerShell injection allows you to then basically take shellcode, inject it straight into memory all through PowerShell. And PowerShell is always whitelisted because it's a native part of the operating system. So if you have PowerShell installed, which is Windows Windows Vista, Windows 7, Windows 8, Server 2008, and Server 2012, you have PowerShell installed. It's there by default. There's no way of removing it, okay? So what you can do is there's a command in Metasploit called psexec_command. Now let me find it real quick. Anybody ever used this one before? You cool, man. Sweet.
I used it with your PowerShell injection.
Hey, that's right. So back in DEF CON like 17 or 18, a guy that's not here unfortunately, he normally comes, but Josh Kelly and myself, we spoke at DEF CON, and it was when PowerShell version 1 had just come out, and we're like, oh my gosh, this is amazing. And so we came up with a bunch of different techniques, and one of them was how to bypass execution restriction policies. So basically, you can circumvent protection mechanisms in PowerShell and execute whatever you want to unfiltered on the machine itself. So even if you have it in the most restrictive mode, which is restricted, you can still circumvent and bypass it. So what we would do here is use auxiliary, admin, SMB, psexec command. And if you do show options on this, notice here it's very similar, okay? So we have SMB user, SMB pass, everything else is pretty much the same. Now the only difference is this allows you to do what's called R hosts, and that's a big deal. R hosts allows you to scan entire CIDR notations, okay? So if I want to scan an entire class C or class B for what are valid credentials that we have here, it'll go and find it for me. So I can enumerate all the machines that I can authenticate to without ever uploading a binary to it. That's important. Second thing is, notice here we have set command, okay? What we're going to do here is we're going to generate a quick PowerShell script that's going to give us a shell very quickly all through PowerShell. And you can do that all through the Social Engineer Toolkit. So if we load up set, we do a social engineering attacks. Now notice the menu here is there's the PowerShell attack vectors, number 10, right here. You select number 10. And then we go to the PowerShell alphanumeric shellcode injector. And what this is going to do is going to generate Metasploit code that's alphanumeric shellcode. And what's going to happen is it's going to take that code, it's going to use PowerShell, it's going to enumerate the kernel 32 base address, it's going to use virtual alloc to allocate memory to the specific stack, and then it's going to inject all of that shellcode into memory under the PowerShell.exe process. And it's all going to bypass everything like whitelisting and antivirus because it never touches disk. So we go to number 1. It wants to know where it needs to connect back to. So here's my attacker machine IP address, which is 9.229. And sorry if I talk too fast. I got a lot to talk about. It generates it, and it asks us if we want to set up our listener now. I'm going to hit no because I'm not going to actually show it. But we're going to go ahead and go to the shellcode real quick, or go to the PowerShell injection. By the way, the Java applet attack already has this PowerShell attack built into it. So when they run the Java applet, it actually looks to see if PowerShell's in there and then injects into memory. If not, it falls back to a few other options. So here's our shellcode right here, basically. This is what it looks like. It's just the PowerShell command. So you just type in set space command, and then you copy and paste this in here, and this is going to decode into memory and shoot the shell back to you, and you're going to have full access without ever touching disk. So just another method through pass-the-hash impersonation that you can use that you might not have known about. That's my favorite, by the way. I use that all the time. Like, especially if I find like SQL servers. Oh, yeah. SQL servers are my favorite because you can use the XP command shell store procedure, drop the PowerShell stuff on there, and then boom, you have a shell all through SQL. It's usually run a system. Pretty cool?
I like the anecdote of Microsoft changing the disclaimer on the encoded command.
So when we did our release of PowerShell, if you looked at the documentation of PowerShell version 1, it said execution restriction policies are a security feature to prevent unauthorized access to PowerShell scripts. Well, when we released our attack, the fix for it, the fix for fixing PowerShell, execution restriction policies are not a security feature to protect against code execution. So it's fixed. Just a funny one. They're actually really good. They're actually really good guys. Really concerned about obviously making things better. So Kerberos impersonation is my favorite by far. This one right here alone is how we make money as pen testers. All right. If we didn't have this and it wasn't in Metasploit, it'd be much more difficult for us to do our jobs. And the best part about it is you can't fix it. That's what sucks. Like there's nothing you can do to fix that. You can't fix pass the hash either. Just don't get owned on your boxes and don't use shared passwords. Problem with Kerberos impersonation. So let's just say the prior 2 steps that you used. You don't allow local admins to log into a machine, okay? And if you do, you log out. And 2, you don't share the same passwords on every single machine, okay? So you don't have servers having the same passwords on each individual machine. It's obfuscated or the administrator account's disabled completely, which you can do, by the way. So say you have those two features licked and you're all set. The problem with Kerberos impersonation is the way that Kerberos works in its ticketing system is when you log into a machine, a Kerberos token is initiated and active on the machine, right? By default, I think it's 12 hours in group policy. So that Kerberos token is valid on that machine for a 12-hour period. When you log off of it, the Kerberos token is still there. It's still valid on that machine. So what happens if I own a box and I compromise it is you have Kerberos tokens that are still valid on there, and as a normal user, I can just go and I can become that Kerberos token, and I'm that domain admin or whoever was logged in that machine. Don't need to know about passwords. Don't need to worry about anything. I just impersonate that token, and all of a sudden now I'm a domain admin. It's like that easy. And that attack would seem really complex, right? Like it would be like a pretty complex attack to have to go in memory. It's literally you have to type in impersonate space token or underscore token and then the name of the user account. Now you're that person. It's like really hard. So let me show you how to do that real quick. Here we go. So I'm just going to go back to the same sessions as I was at last time. I'll just interact with session 16. Now, if I type in a thing called use incognito, it's an extension of Metasploit. Incognito was a tool that was initially really a standalone, but then it was incorporated into Metasploit, which was like the hacker's best day in our entire lives. Like it changed the whole game when it comes to pen testing. Like normally we had to work for our stuff. Now it's just like we don't have to do anything. Like it's just, hey, we just broke in, we got domain admin in like 30 seconds, please, here's our invoice, right? That's like basically what it's come down to with this attack. It's awesome. Obviously, you have to get the entry points in and all that good stuff. But incognito here. Now, in Metasploit, if you just type in help or question mark, it'll show you more stuff here, right? Now, the two things that we're concerned with is the impersonate token and list token. So first, we're going to do list token -u or -g. If you just hit that, you can see the additional syntax. But we're going to do -g just to see what accounts are on here. Now, here's all the permissions that I have available to become, anything I want to. Now, think of the fact that a domain admin logs into a member server, all right, or a elevated permissions individual logs into a member server. You now have those exact same permissions to become that individual based off of group delegation tokens. So now if I want to become this user, I just type in impersonate underscore token built-in / administrators. Now I'm that, okay? So it's that easy. Now there's a really cool thing that not a lot of people know about called Kerberos bouncing. I'll tell you about that in a second. You know about that one?
No.
Yeah, that's what I'm talking about. So if we want to list the users too, you can do list tokens -u, and you can see the users that are logged in this machine. So I'll impersonate Dave. Sorry, you don't need to do -u on that. And you need to do // It's an interpreter thing. So now if you notice here, delegation token available, successfully impersonated username stronghold /Dave. Now I'm that person. I'm that domain admin now. That whoever was logged in that machine with that Kerberos token valid. Very easy, simple attack to do. Now what's really cool about this, a recent pen test that I was on, ridiculously hard. We found SQL injection on the outside, Microsoft SQL injection. It was blind SQL injection, so we had to do a bunch of stuff to get the XP command shell store procedure to work to get our syntax properly. But at the end of the day, we ended up getting our syntax working in the blind SQL injection. Got the XP command shell store procedure to work. Got a shell out of there using PowerShell injection, okay? Now we got our shell, and we're running as network service. Now has anybody ever been on a pen test and running as network service? It sucks. Like running as network service sucks because you have no permissions to anything. You can see like the www or the inet pub directories, but you don't have access to anything. You can't add user accounts. You can barely type in any commands. So it's a really limited user account. Now what I found, and this is purely by just accident, is what incognito will automatically do if you try to do something like this. So first thing I do when I get into a system, by the way, is I drop into a shell. Here, and type ipconfig all. Now, what does this information here tell me? Hang on. What does this information here tell me as an attacker? DNS servers, right? Win servers, possibly. Subnet mask, right? A couple things, right? What are DNS servers typically? Domain controllers, right? What are Win servers typically? Domain controllers, possibly. So you have a good shot of possibly having a domain controller just by typing ipconfig all and learning what's out there. Now that I know potentially what a domain controller is, and I don't know for sure, I can grab and copy that IP address. Let's just say it's 9.2. If I type in add user, and I just type in trusted sec and a password, right there. Now what this does, this command right here inside incognito, is even if you type in list tokens -u or -g and you don't have the permissions to see them, doesn't mean you don't have the permissions to actually impersonate that token. it actually tries to impersonate every token on that device until you find one that you have the permissions to and then add a user account. On this machine that I compromised had a domain admin on it. Impersonated a domain admin with a network service account, boom, have a domain admin on the domain. All set. So, easy way of getting around it. And so if you just type in add user, trusted tech, whatever, it'll sit there and it'll cycle for like 5 minutes. But it's trying every single combination of all those Kerberos tokens that are on that machine until it finds one that you have permission to, or that it has the permissions to add a domain admin, and boom, you have the ability to now authenticate to that server with a domain admin account.
Just to be clear, add user is an incognito command.
Add user is an incognito command. Yes. So when you type in use incognito, it is a incognito command that uses the Kerberos cycling. Now, that was cool, huh? It's my favorites. Just around the Kerberos piece. That's it. Just the functionality you have in Metasploit around that. Now, there's a second thing I'm going to show you here in a second, which is process stealing. And that's built inside Metasploit as well. And process stealing is another great one that I use all the time. Remember when I typed in PS and I was trying to migrate to different hosts? Well, those processes are run by individual owners, right? So you have system maybe that's running a few. You have different user accounts that may be that have logged in. They may be looking at Internet Explorer. They may be doing whatever. What you can also do is migrate those processes and become them, or steal a token. I'll show you that real quick. So if I type in PS, you can see here that that Stronghold Dave is the guy that I want to be. So notice here, Stronghold Dave. I look over here. Here's my process ID, 5048. To become Dave now, again, really complex. You know that user. So you steal that token, and now you're running in that individual process. So now you become that user. You have full access to whatever rights they have. Okay? What's that? No. You're just stealing the token that's in that process. The process is still legitimately running, no problem. So you don't notice any difference. The user wouldn't see anything on his end. Completely transparent. You will lose. No, since you're already running as that token, you'd be fine. Yeah, you just stole a token off of that, and you're impersonating that token, so you're all set. So if the process is closed, you'd be fine. Now, if you're running in a process, and that's why I don't like running IE exploits and stuff like that, because if I'm running an IE exploit, for example, and a buffer overflow or whatnot, and I compromise somebody, as soon as they close IE, I'm screwed, right? Unless I've migrated processes over. That's why doing something like the Java app attack, it hooks itself into multiple other processes, so you don't have to worry about them closing the browser. Good questions. Any questions so far? Pretty sweet, huh? No, steal token is actually built into Meterpreter. You don't need to load any extra modules, so it's not an incognito module. And incognito is built into Meterpreter by default. The only one that I've shown that isn't is Session Dump. Session Dump I had to manually add myself. Okay, but Mimikatz, the one that you saw with the W digest getting extracted, that was just added to the trunk, I think like yesterday or last week sometime. So that's already in there. Session Dump you have to manually add. Incognito is built in by default since like 2006 or 7 or 8 maybe. Yeah. SMB exec, I found the most horrible picture I could find of Eric, and it worked out well. Sorry, Eric, if you see this. But he's a good buddy of mine. Eric wrote a tool called SMB exec, which I use all the time, and it's basically pass the hash on steroids. Allows you to, what SMB exec will do is it'll automatically scan for those that have the SMB service open for you. It'll allow you to import your own binary, and then it'll actually do pass the hash for you automatically and give you all your shells basically raining back. So you have like shells that are just hitting back and forth. So you have a million shells that are running, and then you can just use them. So it works out well. Good stuff. Anybody heard about the group policy hack? That's a big oopsie. So one of my personal favorites, and this is one I did I think last year at B-Sides too. But what happened was, so has anybody set, and this isn't wrong if you do it. This is how you're taught to do things, right? Has anybody set their local admin passwords on their servers or their workstations or any SQL service accounts or any service accounts through Active Directory? Anybody? Almost everybody, right? Bad, really bad. And reason being is, so when you authenticate to a server, you log in with a normal user account. Let's just say my name's Bob, and I have just domain users permissions, okay? I log in my username, I log in my password, right? I don't have access to anything, right? Well, the problem is, when you log into your computer, your machine contacts out to the sysfile share and looks for certain things, right? So it pulls its group policy settings, it pulls any type of computer settings, anything that it needs to pull from the domain infrastructure itself, it pulls from that sysfile share in that domain controller. So when you set the password through group policy, what happens is there's a groups.xml file that gets created. And inside of there's a kpassword variable. That kpassword variable is your admin password in a 256 AES encrypted string, okay? Which is good, right? 256 AES is solid, right? Well, unfortunately, and this is the C password, not kpassword. That's the encrypted hash value right there. Unfortunately, Microsoft posted the static keys on TechNet for the entire world. So, as a normal user, I can go and I can authenticate to a domain controller, grab that groups.xml file, and decrypt your clear text password because it's uniformly the same for Server 2012, Server 2008, Server 2003, you name it, you got it, right? Here's the code, the Python code to just do a quick decrypt. And here's it actually decrypted. And so it doesn't matter how complex a password is, you can just decrypt it as a normal user account. So if you have a domain user account, you can elevate yourself to whatever you want to if you set it through group policy. What did I do there? Oh, back up. Now, if you want to take the lazy man's approach, which is what I typically do in this type of situation, instead of having to go to like a domain controller and actually sift through it, that's not good. Why did that do that? Probably updates. What you can do is there's a script in Metasploit. So once you get an interpreter shell in a box, like say I do social engineering and I compromise Bob. Bob is a normal user account. There's a script that will automatically grab the policy settings on the machine, find all the domains that are listed, log into each domain that's available to that individual user, Bob's account sysfile share, search for the groups.xml file, pull it back and decrypt it for you automatically. So all you need to do is type in run post windows gather GPP. GPP? Maybe it's not in gather, hang on. Where's it at? GPP, credentials, sorry. That was close. So when you run that command, it'll automatically reach out to all the domain controllers for you, find the groups.xml file, decrypt it for you, and give you the clear text password for you automatically. So that was a cool one.
Has Microsoft said anything about this?
Nope. It's been, it was discovered in 2011, and it's been the same since. No responses, I don't think, at least not that I'm aware of. And it's still the same. What's the new standard? What's that? What's that? Don't set it through group policy. That's the only thing I can explain. Now, what I typically do and what I recommend is I actually have a blog on TrustedSec. If you Google TrustedSec disable local admins, what we did when I was a CSO over at Diebold is we actually ran a scheduled task that would automatically go and disable the local admin account every 2 minutes or so. And we just didn't use the local admin account. Now, here's the biggest argument that sysadmins will have, is if the local admin account's disabled, if it loses its permissions to the domain, how am I supposed to log into it? Now, what you can do is you can reboot a machine into safe mode, and it'll automatically re-enable that admin account for you so you can still do your troubleshooting and rejoin into the domain. So you should be able to at least eliminate local admins from the servers themselves, which actually eliminates a much larger exposure for you as an attacker. So I definitely recommend disabling local admin accounts. And there's two methods of doing it. I prefer the group policy method. I don't know if you know this or not, but in Server 2003, you could disable a local admin account in group policy. In Server 2008 and above, if you actually put disable local admin account, it doesn't disable it. Because you have to have another local admin box on the machine before it'll actually disable that account, or else it won't disable it at all. So you actually have to do it through group policy if you actually want to eliminate that local admin account. All right. So just a couple other things. Some more guys at Root Dance did some more research and found like service accounts, scheduled tasks, SQL servers are all impacted with this. So they're all stored in the groups.xml file. So if you do any of those inside of group policy, you're affected. Here's some of the affected areas here: printers, drivers, everything, drives. Any questions on the password stuff?
You said that if you use unique passwords on the server,
Yeah. As long as so unique passwords are an interesting one. So if you can do some sort of way of like maybe pulling the hardware ID with a couple other things, something that you know is predictable, at least that you can still log in, that definitely makes it much more difficult for an attacker, especially if I'm not going to crack a password. If you have a really complex password, it's going to be hard for me to either crack that, but make it so it's not something easy like computer name plus the date plus the time. I'm probably going to get that as an attacker, right? So I'll probably get that as an idea to go in there. But good question. Any other questions? All right, why don't we take a quick 10-minute break, and then we'll get into EMET. All right.
Thanks for speaker, Dave. Good job.
What's up, bro?